Very good afternoon, friends. Once again, welcome to your own channel, Beam Athlete. I once again welcome you to the second video of this chapter. That is, chapter name is Differentiation. Yesterday we have seen the basic algebra of differentiation, addition. If a given function y is addition of two functions, if it is subtraction of two functions, if y is a product of two functions u and v, then that is a product rule. If y is a division of two functions, let's suppose y is equal to f of y is equal to u by v, that time that is the quotient rule. Okay, yesterday we have seen the definition of composite function. So composite function means a function like it's inscribed in other function. Okay, its example also we had seen yesterday. If y is equal to log of tan of e raised to x. Okay, so now we are going to proceed in this video. We are going to learn chain rule. So chain rule is mainly used to differentiate the composite function, and this chain rule I will explain you using one theorem, and that theorem that we are going to deal with that theorem now. So if y is equal to f of u is a differentiable function of u and u is equal to g of x is a differentiable function of x. See what is given. Y is a differentiable function of u. It means we can differentiate y with respect to u. That means derivative of y exists with respect to u. That means dy by du we can find out. We can't find out here dy by dx because y has not given the differentiable function of x. What has given? Y is differentiable function of u. Okay, the same thing, u which is inscribed in f is a function of, it is expressed in another function. U is equal to g of x. It means u is differentiable function of x, isn't it? So in this case, such that the function, the composite, such that the composite function C, what is given? Such that the composite function C, initially in left hand side there is a y is equal to f of C u, but u is given in g of x is a differentiable function of x, is a differentiable function of x. Then if we want to find out dy by dx, then we will be having the formula dy by y is given in u, so we will differentiate y with respect to u, and u is given in x, so we will differentiate u with respect to x. So this is nothing but the chain rule. This is nothing but the chain rule. Now we are going to prove that if we want to find out dy by dx, then that will be equal to dy by du into du by dx. First of all, friends, we need to understand the meaning of composite function. So see, this is one of the best example of composite function. Okay, so y is given in u, so we can say that we can find out dy by du. Why we can find out? Because y has been given in u. In the same way, u is given in x, it means we can find out du by dx. But in overall, if we want to find out y with respect to x, now it has become the composite function. Why? Because y is given in u and u is given in x, so it has become y is equal to f of g of x, isn't it? So we will find out dy by dx by using the formula dy by du into du by dx. This is the theorem's proof. We need to prove this. And this is what the chain rule. Now we are going to prove this. Now friends, see what has given. It has given that y is equal to f of u. Y is a function of u. Just I have explained in the proof of that. And u is equal to g of x. That means u is a function of x. Now we will assume that in this case this u has been given to us, no? That u is not a constant function. Okay, now u is not a constant function. Now let there exists a small increment in x that be delta x. So as delta x is a small increment in x, so we will consider delta y and delta u be the small increments in y and u respectively. And friends, these increments are such that this delta x, delta y and delta z, they are not, delta u, they are not equal to 0. It means we have to take the increments in x, y and u in such a way that they are not a single of them are 0. Okay, so now we can write how. See, if I will write delta y upon delta x. Okay, now this numerator I will consider as it is, keep as it is, denominator I have kept as it is. So what I have done here, I have divided numerator and denominator by delta u. Now the numerator part will remain as it is, and this denominator part which is in the division, but it will go if we want to bring it in the multiplication. So this delta u will come in the numerator and delta x will go in the denominator. It's very simple, friends. Once again I will repeat it. What I have taken, delta y by delta x, isn't it? See what I have done. I have taken this delta. This is not the dy by dx. First of all, one thing students, they have to clear in their mind that, see, this is not the dy by dx. I cannot write dy by dx because y is not the function of x. Y is the function of u, which is given in the statement part of the theorem. This is a delta y by delta x. I have continued with this delta y, here delta x. What new thing I have done here? I have divided numerator and denominator by delta u, isn't it? So it has become delta y by delta u. The term which is in the denominator it will go in the multiplication, delta v u will come in the numerator and delta x will go in the denominator. I think this much part is very clear. Now what we will do, we will taking limit delta x tends to 0 on both sides, on both the sides of above. So what we are going to do, we are going to take limit delta x tends to 0 to both the sides of above equation. So we have taken limit delta x tends to 0 to both the sides of above equation. This is the above equation. See, delta y by delta x. So I have taken limit to the right hand side of the above equation. Also I have taken delta x upon delta x tends to 0. So we have taken separate limits. Delta x tends to 0 into this, into delta x tends to 0 into delta u by delta x, as y is a differentiable what function. Y is a differentiable function of u. That means, that is, or it implies, as y is differentiable function of u, that means dy by du is equal to limit delta u tends to 0 delta y upon delta u, and u is a differentiable function. See friends, it's very simple. What I have done, I have taken limit to both the sides, as it is given to us that y is differentiable function of x. Y is a differentiable function of x. That's why we can find out derivative of y with respect to u by the definition of differentiation. As y is given in u, so y is differentiable with respect to u. That's why dy by du is equal to limit. The increment in u is delta u tends to 0, delta y by delta u. The same thing will happen for u. U is differentiable function of x. So by the definition of derivative, derivative of u with respect to x, that is a du by dx is equal to increment in x, that is a delta x tends to 0, delta u by delta x. So this equation number 1, which, see, this is equation number 1. This step, see, we need here delta u, but what has come here? Delta x. So we have to adjust delta x by delta u. We know as delta x doesn't tend to 0, delta y and delta u. But if as delta x is tending to 0, so delta u will also tends to 0. Why? Because that are the small increment in x and u respectively, and at the given 3 out of 3 are not equal to 0. But if one is tending to 0, that means the remaining 2 will also tends to 0. In this case, delta x is tending to 0. That's why delta u will also tends to 0. We will replace this delta x by delta u, because ultimately, understand now? Ultimately both are tending to 0. See, both are tending to 0. So what is my work is there now? I will replace this delta x by this delta u. So this equation number 1 I will rewrite here. See, I am replacing delta x by delta u. and I will keep this delta x as it is. So this is the very important step of this equation. Now see what is happening by the definition of derivative. Limit delta u tends to 0 delta y by delta u. See here, limit delta u tends to 0 delta by delta is nothing but the dy by du. So I will replace this by dy by du, dy by du. This into will remain as it is, and this latter part, the second, see here, second term, limit delta x tends to 0 delta u by delta x. Just see here somewhere, this limit delta x tends to 0 delta u by delta x is nothing but du by dx. So I will replace this by du by dx. So we have, friends, now we are arrived to this step, that limit delta x tends to 0 delta y by delta x is equal to dy by d into du by dx. If you will see carefully, then we will understand the right hand side of this equation exists as, what I will write, as right hand side of above equation exists. So left hand side will also exist. What it means, see, this is equation, this is left hand side, this is the right hand side, in between there is equal to, this right hand side exists, it means this also exists. This exists means what? This exists means this limit exists. This limit exists means dy by dx is equal to limit delta x tends to 0 delta y by delta x. So here I will replace dy by dx is equal to dy by du into du by dx. So that only we wanted to prove, isn't it? What we have proved? Small recap. What we have proved? So we have proved that if y is a function of u is a function of x, then the function y is equal to f of g of x. This is a composite function. Why composite? Means combo means combined. This g is combined in f. Have you seen at home your mother, she put a small box in a big box, again a small box in the small, and that again a box, like small boxes are kept in the big one, isn't it? So you get the combo of that, the combination of that. The same way the outer function is f, g is inscribed in that. So this is a composite function, and if you want to differentiate this composite function y with respect to x, that time you need to know the chain rule. So what is the chain rule? Dy by dx is equal to dy by du into du by dx. This we have proved here. So this theorem, friends, is really very important to solve composite function. This theorem is known as chain rule. Okay, and these theorems comes for 3 marks in board exams. Okay, so to solve the problems on chain rule, to solve the problems of composite function, you first of all you should know the chain rule. Okay, so now friends, we will see some points, some notes You need to note this and you need to keep these things in your mind. Okay, so first point is that if y is a function of u, okay, y is differentiable with respect to u, that means we can find out dy by du. U is a function of g, u is a function of x, we can find out du by dx. So which composite function forms here? Here it forms as y is equal to f of g of x. So while taking derivative of y with respect to x,